Hello, everybody. In this video, I'm going to be discussing the nomenclature of organic compound. That's called naming of organic compound. Organic compounds. So when you're talking about naming of compounds, we are talking about IUPAC nomenclature, or International Union of Pure and Applied Chemistry nomenclature. So the naming could have traditional names, popular name, but we are using IUPAC, International Union of Pure and Applied Chemistry, that groups guidance in naming organic compounds. So what I'm teaching here may be a bit beyond your level unless you're doing, you're majoring in chemistry. So I will try to have a middle ground here, but mention certain terms you may want to hear at this level in case you go on to major in chemistry. So there are steps to understand or to get used to an easier way of remembering things when it comes to naming of compounds. Okay. So first of all, there are three main parts in an organic compound if you're following the IUPAC nomenclature. So we will divide it like that and then study each part separately. Okay. So always, when you use the systematic naming, there'll be a substituent group that will be the prefix. Then there's a skeleton name. And then you have the class name. That is the suffix. Prefix, skeleton name in the middle, then suffix. When it comes to skeleton name, it identifies the carbon skeleton, because using this is about organic compound, so we consider carbon. So it identifies carbon skeleton, C skeleton. Okay, so whether it has 8 carbons, octane, or if it's an alkane, oct part, non if it is 9, those things. So that's the skeleton part. Now this class name, it relates to the functional group, or if it has double or triple bonds. So functional group or double or triple bonds would be given by the suffix. Skeleton is number of carbon atoms determining, or the skeleton of the compound. It's a cyclo compound, or it is an aliphatic, that sort of thing. Okay. This is just telling the substituent that is attached, maybe an alkyl group or some other group. Now, depending on the level of study you are doing, you might have only one functional group. But if you have more than one functional group, then you have to go for the priority order and then name the other, take the prioritized functional group as in the main chain, the skeleton attached to that, and suffix is made out of that functional group, and the other one would be a substitute. Okay. So that's how it goes. When you're doing that, always remember halides, which I denote as X, halides, nitro groups, they will always be substituent groups. If they have only, if the compound only has this halide and nitro groups, then we name them as a derivative of hydrocarbons. Let me go through this again, because this is the beginning. So IUPAC naming of compounds, first of all, the name would have three parts: a prefix, a skeleton name, and a suffix. Prefix is substituents that are attached to it. Skeleton names tell whether it has how many carbons and with the cycle or not. Then class name, which is the suffix part, tells us which functional group, or if it has a double bond or triple bond. Okay. Now the identification of which one we consider the one we are going to put suffix as a part of the suffix, we say we have two functional groups. Then one would be the priority group. In the order, one would be higher. So we put that as the suffix, and the other one we use as a substituent. So substituent could be any R group, could be substituent too. R means alkyl group. But if we take halides, which is ionic form of halogens, or NO2 nitro, we consider them always substituents, and if they come as prefixes. But if they are the only ones in the group, no other functional groups are there, then we name them as derivatives of hydrocarbons. H means hydrocarbons. Okay, so that's the first part. Now I told you, when it comes to the class names, we had to have a priority group, because when you're going to name a compound, we find the chain or the cycle with that functional group, or double bond, triple bond. That is the priority. But when it comes to functional groups, we have to identify which functional group we are going to refer to, and there's a priority order. So I will write them down here. It's important to remember, depending on the level of study you are doing. Okay, so let me write priority order here. The functional group, class name. Why I put class name? If that is the prioritized functional group, then you have a class name. That is the suffix. That means it comes at the end of the name. In the event it doesn't come as the end of the, it is not the priority group, then we put it as a substituent. Substituent name, which is the suffix. Okay. Try to fit in as much as possible. Okay. So the first one, is carboxylic acid group. Now you know I have done a video previously about whether molecular formula, skeletal formula, or displayed formula. So I'm doing the skeletal. Okay. This is COOH. That's right. So the class name is going to be whatever that skeletal name, oic acid, which has to be added. But if it becomes a substituent, then you put carboxy. Okay, carboxy. Second one. That is sulfonic. Okay, that's the sulfonic group. When I was doing functional groups, I mentioned the sulfonic group. So it will have the suffix. I'll write with pH, SULPH, sulfonic acid. So if it is a substituent, we put sulfur. You might say SULF for sulfur. So then the third one. There's a group. We'll learn this about this later. So I'll show it. I put it. It's an alkoxy group. If it is going to make the main chain, then we call it O8. Ends with OATE. Otherwise, it is alkoxy carbonate. Right here. One word. Alkoxy carbonate. Okay. Fourth one. We have X attached. That is oil halide, whatever that name. Oil halide, and this it is substituent group here. Halo formula. Halo, like chlorobromo. Halo for male. This is the connecting one. Yeah, I put alkoxy carbonate is one word, then it's connected to that. Okay. Fifth one. Now I didn't have to write this carbonate, but I'm just writing it. So this is if you have that one, it's an amide. Carbonamide, like amide. And then this is connecting because that's the end part. If it is a substituent group, then we call or carboxyamido. Carboxy. Sixth one. So N will be al, and if it is a suffix, sorry, prefix here, I'm sorry. List all the things. So this is a prefix. Just telling it and put it. So that is prefix, okay? Because that's the beginning. So at the if it's beginning, then this is al, and it will be formyl or oxo. So these are the ones you put in front. So that's our prefix. It's prefix. Seventh in the order. So the first, if you have a functional group, if you have a chain, if it has carboxylic acid group here, the number one, then this one, then you use that as the main chain and give priority to that functional group. Okay. That's why this order, that's what it means. Okay. So the next seventh one is if it is the suffix, naming the compound, and the end, it will end as nitrile. And if it is the prefix, the beginning, then cyano, because this is a C. Triple bond N is cyan. Then eighth one, yeah, that on, that is the ketone part coming on, ending with like al. And this is on. And if it is from, then it's keto or oxo. Then the ninth one, this one, that's all alcohol, that's why. Otherwise in the front it is hydrox. Then if it is the 10th one, it's the 10th one, is NH2, then it's you call amine, and if it is beginning, that is amino. See the difference? AMINE, and the other amino. That's it. Amino acid. When it's prefixed amino, acid is given the priority because carboxylic acid. So amino acid. That's how it goes. Okay. 11th one. We're attaching. You should recognize this by now. That is ether. So just to make it, a suffix means the end part. That's the front part. Okay. So ether. Front we call alkoxy. Here alkoxy carbonate. Here alkoxy. Okay. Then the 12th one. We have C with bonds called ine. We have talked about this before, and even the prefix is still ine. Let us try to get 13 and 14 here if I can. 13 in the last two. The 13 is just double bond. You know this about ene. The other way too. This is also ene, and then if we have what we talked about X or NO2, the suffix is remaining as if it is a hydrocarbon alkane. We don't change anything, and the adding ones we call it either halo or nitro. Halo or nitro means depending on if it is a X, then halo. If it is NO2, nitro. Okay, just remember. So that's the priority order. So once you have this one, you can first of all determine the class name by looking at the compound with that, the longest chain that has the functional group priority 1, 2, 3, 4 in that order. Always the step 1 is determination of class name. Now that you know the priority order, determination of class name. So according to the priority order, we select which one we should give the priority order. Okay, so we'll say you have a compound. I just give an example first, right? H3C, CH, just making this up so that to understand. This is the longest chain. It has 2 functional groups here. We have to look the priority order. Okay, in this, the functional groups are, we have group, aldehyde part, and we have COH, which is alcohol. Okay. Now we know from that list, this has the priority over COH. This has the priority. Therefore, our naming is going to end with al because it's aldehyde. This is aldehyde functional group. There were 2, alcohol and aldehyde. Out of that, in that list, aldehyde comes before alcohol. So that's why we do that. Another one. Right. This is one functional group. OH again. So we have an alcohol and amine group. Out of that, the list OH has the priority over NH2. So it will end as all. That's what it means. Okay. So that's what it means, determination of class name. So we select the chain that has the functional group with the highest priority. That's what we do first. Then determination of skeletal name. So skeletal, we have to know whether it is aliphatic, whether it is alicyclic. I did the classification, so if you watch that video, you will see what is aliphatic, what is alicyclic, aromatic, or heterocyclic. Okay. So the skeletal name, we find whether it is aliphatic, alicyclic, aromatic, heterocyclic by first we identify the functional group, the highest priority order. Highest priority. The chain that has the highest priority order would determine whether it's aliphatic one, alicyclic, aromatic, or heterocyclic, because whatever the section that is attached to this, the highest functional group, what I mean highest priority group, is the one we are going to select as the skeletal name, the middle one. Okay. So clear that one. Let's give you an example. Okay. So we have function group here, function group here. The priority is this one, right? OH is over NH2. So out of that, this is the one we are selecting. So OH has the priority over NH2 as a functional group. Therefore, we know the compound will have the class name OL. Okay. So it's the same thing if you have a chain. We select the one with the triple bond over the double bond one. Remember that. So it is because triple bond has the priority over the other one. That's so in this case, we can see that OH is attached to the cycle. So it's going to end up as all. So, and OH is attached to the aromatic carbon. So therefore, this is the prioritized functional group. It is attached to the aromatic. So it will follow the naming of aromatic compounds because the main functional group is attached to that. Okay. Now, then it starts going deeper into that. After you selected the main functional group, like in this case, and after you select whether it's aromatic, aliphatic, because it's connected to aromatic, that's why we go for aromatic. If it's connected to an aliphatic, that's just a chain, no cycle ones or aromatic ones. Then we name it accordingly. Then you follow these steps. I'm going to tell you now. in that order. So first you determine the functional group. If you have more than one, then you determine which one has the priority. Then you determine whether it is connected to an aromatic, alicyclic, or aliphatic, or heterocyclic compounds. Just go and check the classification of compounds if you don't understand this part, okay? Or if you're confused about what they are. Then you follow this one. This goes step by step, right? After you do the first part, then you see all other functional groups, all other functional groups are substituents, okay? Are substituents. But if the carbon skeleton, I'll write it so you, if the carbon skeleton, I know my handwriting is not good, but I'm talking as well because these are unedited videos. So if the carbon skeleton has a double or triple bond, okay, alkene, these are considered substituted groups. That skeleton you selected, which has the highest prioritized functional group, any other functional group is going to be substituents. But if they have double and triple bonds in that chain, we call them subsidiary groups. They are subsidiary group. Okay. So only double and triple bonds we call subsidiary groups. So what it necessitates is to adjust that skeleton name. So we have to adjust skeleton name of the middle part name. So it will tell us whether it has a double or triple bond in the system. That's what it means. Okay. So clear this so more space. When selecting the main chain, when you're selecting the main chain, we'll say we know that you select the one with the functional group, main one. Now, first you select the chain that contains the main functional group. Then I'm going on to detail within rules, sub-rules. The reason is because suppose we have two chains that have the same functional group, then what to do? That's what, okay? So you select the main chain according to, or to include the functional group with the highest priority order. Okay, that main chain, this is useful if you have two functional groups that are the same, but that should include the maximum possible number of double or triple bonds. This main chain, so So if you have two options, you go for the one with if you have two chains that have the same number of carbon atoms, but then we go for the chain with the maximum number of double or triple bonds, which are subsidiary groups. The main chain must have maximum number of double or triple bonds, which we also call as subsidiary groups. Okay. Then after that, we go for the chain with the maximum. So you see the order coming first, the functional groups. Then if you have the functional group, then you go for the number is double or triple chains. Then we go to chain with the maximum number of C atoms. Now, normally you start here, right? When you do alkane, they say chain with the maximum number of C atoms because you don't have to bother with functional groups, so you don't have to double or triple bond. That's the reason you start telling carbon atoms. Okay. The first carbon, this is important to know. The first carbon atom, because it's numbering, okay, the first carbon atom should be from the main functional group. Okay, so if we have a case like this, that's number 1, 2, 3. It starts with 1, the one that is attached to the functional group. It's a part of the functional group. Okay. Then we go to that. If you're just studying alkane naming, then it should have the maximum number of substituents. Maximum substituents. Substituents, we have given the names if it is functional group, if it is X and NO we have given, or it could be any alkyl groups too. Okay, R groups. Then you do the last one, E, which is you name the skeleton according to the number of carbon atoms. Name according to the number of carbon atoms. C atoms. Okay. So that's how we do that. So a small example. Yeah. Let's say I have a case here, CH2, okay. CH2C, CH2, CH2, C, CH2, C. Okay. Now my main chain could be 1. Okay. Let me use a different color. It could be 1, 2, 3, 4. Because I select the chain and then 1, 2, 3. Right. So I have the option. We'll go step by step. Right. So the first one is detect the functional group. This is the functional group. We select the chain with the functional group. This chain is okay. This chain is okay. Or this chain, right? Those two chains, both are okay. Take them off, okay? Okay. So then, can you remember we said the chain should have the maximum number of double or triple bonds. Therefore, the correct chain would be this chain. Like this. That's the one correct one. Then you count the maximum number of carbon atoms. So once we decide that there's no other number of carbon atoms going for that, because the order is select the functional group according to the priority, make sure that is attached to the main chain, or the main chain is the one that has that functional group in the first priority order. And then if we have two options, then we go to the one with the more number of double or triple bonds. Now here, this case, if we had gone this way, number of carbon atoms more, 1, 2, 3, 4, 5, 6. But by going through that, we make sure that double bond there. If there was a triple bond, if there was triple bond here, we go that route. Okay, because of the triple, then double bond, because that's the order of the priority. So these are subsidiary groups. That's why we call them subsidiary groups. Okay. All right. So then we have done that part. So we selected this as the things following the rules. Then you take the other ones as substituent groups. These are. So then if you have the option, then we go for the one with the most substituent groups. When you say the option, if you have two choices, we narrow it down by that. But in this case, this is the only substituent groups. It's an R group. Sorry, this is CH2, CH3. So this is an ethyl group, right? Then you name them. Sorry, not name, number them. You number the carbon atoms by giving the priority or the first carbon to the one that is attached to the functional groups or that creates the functional group. So 1, 2, 3, 4. Okay. So that's right. So when you name, you put the substituent groups at the beginning because that's what we said, the prefix part. And then we had the suffix, right? So suffix is always going to be oic acid. Check that table. And this has 1, 2, 3, 4 carbons. So you should have but. It would have been butanoic acid, but there's a double bond there. So we have to say which point the double bond starts at 3. So but 3, it's ene, double bond is ene. So put ene oic acid, right? But then substituent comes at the front. So you put it's ethyl and it's in the third position too. So 3 ethyl or butanoic acid. Okay, this is simple B. Okay, now butanoic acid. So always remember you put hyphens, hyphen, hyphens. Unless there are double, we say you have another ethyl group here. Then you put 3 di, but in this case it's not there. Okay. It's but 3 enoic acid. There should be hyphen 3. That's how you do that. Okay. Now the root name, which is whether we are talking but or something, then we have those ones. There's a naming system. Okay, so the root name but came because there were 4 carbon atoms. So it's better for you to remember this. Let me clear this and put it. If you have 1 carbon, you call meth root. 2 carbons, then you say ETH. 3 carbons, it is prop. 4 carbons, it is but. But 5 carbons, it is pent. 6 carbons, hex. 7 carbons, hept. Carbons. 9 carbons, non. Carbons. 11 carbons, I'll do it on 12, right? On deck. 12 carbons, dodec. So that's how we did it. So you can find the other ones. But so these are the root names that comes when you know the number of carbon atoms. Okay. So whenever there's a double bond, you put in between and say which carbon to which carbon it is attached. You always put the lowest number of carbon because carbon bond is attached to 2 carbons, right? If this is 2, 3, you say 2. You don't say 3 because then people say it's connected to 3. You give the number of the carbon atoms to which it is connected first. Okay. See what other things. So then now the numbering of carbon atoms, the numbering system, there are rules for that. Okay. Now let me talk about those rules. So I hope you understand the other one. So root numbering means you give the first number to the principal function number. Rules for numbering. You have to follow this order. Smallest number to the C of the principal functional group. Okay. The second one. Now, so that's the numbering. If you're naming, when you name, we'll say it has double and triple bonds. When you name it, naming. Naming should be done in the alphabetical order, because E comes before I. Okay, that's the, okay. So number it. So this is naming part. When you number it, these double and triple bonds should get the lowest numbers. Okay. So when you name it, you put in before ein, and you give the lowest possible numbers to double bonds and triple bonds. Now, if we have the choice of name, we'll say I would give triple bond the lowest, then the double, because that's okay, because triple bond has the priority. So you get 1, 2, 3, 4, 5. So it will be, this is 5 carbon, so it will be pent, the root name pent, and you put naming, you put in first, so it will be 3. You let's say the lowest first one, 3 in hyphen 1 pent 3 in 1 I, that sort of things. This way, both double and triple bond both get the lowest. If I name it other way, 1, 2, 3, 4, 5. So 4 and 3. This is 1 and 3. That's right. Okay. 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 So according to the rules, when you number it, try to give, if there's a tie, try to get in double bond the lowest number if you have a try, because it comes first. So follow that. If a compound doesn't have any functional groups, but it has only alkyl groups, you have to, so if a compound, I can't remember the rule, but if the compound has only R groups, okay, or substituent groups, then you try to give the lowest possible number, as I said, depending on what level of studies you're doing, lowest possible number, you give the lowest possible number to the carbon, to the substituent, to one group at the first point of difference, at the first point elaborate on this one. Loads of things. So let us see. If I number in this 1, 2, 3, 4, 5, 6, 8. That's one form. And then the other way is, let me use a different color. 1, 2, 3, 5, 6, 7, 8. Right. So lowest possible number to the first point of difference. Right. Now the first point of difference. Now here the bottom one, if I take the bottom one, I get 2 for CH3, 4 for CH2, CH3, and 7 for CH3. The top numbering gives CH3 and 5 for CH2, CH3, and 7 again for CH3, right? So the out of, according to this, the bottom gives the is 4 is the lowest number at the point of difference. This is 2, 2, 7, 7, 7. The point of difference, 4 is the lowest. So we go by that number. That's what it means by go for the lower number. Now, if somewhere, this is difficult to explain, but if you have a case where the same numbering comes, whatever way you do, for an example, so 1, 2, 3, 4, top 1, 2, 3, 4, both ways is the same. Then which one are we going to select? You select the one that gives the lowest number when you are naming according to the alphabetical order, because when you're naming, you name them according to the alphabetical order. So we select the one that gives the lowest number. Lowest number. Lowest number to the first letter. The name according to the alphabet. Okay. Now, what it means is when it is, so it is nitro, bromine. First letter B is in the alphabet first, then N. So we have to get the top one. I'm sorry, the bottom one that gives the lowest number. So 2 bromo. Numbering is correct than the 3 bromo. That's what it means. Okay, so that's how we do the naming. And I want to emphasize, because I don't know whether I mentioned, but if you have double and triple bonds, and if it gives the same root 1, 2, 3, 4, 1, 2, 3, 4, try to give the one carbon with a double bond gets the lowest, because then again it's the one that is coming first in the, when you're naming it according to the alphabet. Iron comes at the bottom, right? So try to give the numbering to the lowest one, provided this is attached to the bigger functional group. Okay, if it's not a functional group, then the priority comes to the triple bond, because triple bond has the priority over double bond. But what I'm telling is, once you've selected the functional group, and if the numbering comes to the same, you try to number it in a way that double bond gets the low one, because once again, double bond, ene comes before ion. That's it. Okay. So when it comes to the suffix, when you're naming the suffix, you don't put 1, because first carbon is a part of the functional group. Therefore, we don't put that one. But if there are more than one functional group, then yes, we use di, tri, those things. But if it's a substituent groups, we don't count them as for the when you're considering the alphabetical order, we don't consider di, tri thing, but we do consider iso and neo names. So what is an iso and neo, or secondary butyl, tertiary butyl? I will just show you, because those are different ways of naming the compound, but they count. So if you have a structure like this, 3, so it's not connecting. That is called iso, 3 carbons, propyl. It's the alkyl. Okay. Similar to that, if you have, when I do isomers, I will talk about this, but more beyond that. This one, like that, connecting here. That is because you can see that same structure here to that. Then it becomes iso butane. Then if you have something like that, called secondary butyl. That is called tertiary butyl. Okay. If you have this group, these are the groups you have to remember. That is vinyl group. And if you have CH2, two groups, that is allyl group. Just remember these ones. Depending on the level of study you are doing, you get this naming of compounds. Okay. Now, when it comes to ether, different names used, because if you take something like this, H3C, H2C, CH2, CH3, the pattern of naming and the priority order is right. Okay, but these are the exceptional cases. Like now, this is a diethyl ether. And just say common name diethyl, because this is ethyl. This the functional group is ether. Then ethyl here. So diethyl ether. That's what it means. Ethyl groups, diethyl ether. Okay. Or ethyl 1 ether. Ethyl, this part, and it is connected to 1. This ether, ethyl 1 say 2. But if you're going to IUPAC name, look at the table I showed you before, ethoxy, because this is the ethoxy. So these are the naming. Primary, secondary, tertiary are the isomers of a particular compound you can have. Okay. Now, similar to that, when it comes to aromatic compounds, then again there is a priority order. If you are talking, so first we decided, given the functional group, it is an aliphatic, that's just long chain. But if it is an aromatic group, you have, and I won't go into detail in this one. So the first priority is given to benzoic acid. It will look like this. If you decided and say, oh, this is a aromatic naming, then we go this as benzoic. The second one is after the main priority group. The second group is alkyl or alkyl benzoate. Benzene, sulfonic acid. So just remember those ones, the way it's coming. And the priority could go on and on for the whole of the things, okay? But that is moving beyond, as I said, that I just mentioned, and stay in the middle. But all what I mentioned before, they are going to be useful for whatever level you're going to be studying, okay? So that's all. I'm not going to go into details, but then when you're naming of aromatic compounds, when the substituents are attached to it, name the main one, the main group. Say OH, this attached. Any other substituent, you give the priority to that 1, 2, 3, 4, 5, 6, and then you name whatever the substituent group attached to this. Okay, so if it is, we say that CH3 groups, it will be 2,3-di methyl benzoic acid. That's all. So this is 2,3-di methyl benzoic. So dimethyl benzoic acid. And the naming again going to be that in the alphabetical order, you don't consider D as the first one. It's only the name, the correct name. Okay. And then when you're naming these, if you take the functional group, this as the functional group, this the second position, this being the first, second position, and 2, 3, 4, 5, 6. 2 and 6 are called ortho. Instead of telling 1, 6, we can say ortho. Then 3 and 4 called meta. This is 2 and 6 ortho. Meta is 3 and 5, and 4 is para. Those are the position names we give. I'm not going to go beyond that because we might get lost in the first round. So we have studied the things, and the rest, they follow the same one. It is a matter of understanding or remembering the names. Okay, so you know that aliphatic naming compounds, when it comes to aromatic, there is a priority. I gave you some of the things, and the naming start with the cycle. You give the first position to the carbon that is attached to the main functional groups, and that's how we do that. So you should be able to draw a structure when they give the name, or give the name when they give the structure. Those are the things. Another video on isomers to clarify more of the things, so you will know iso, tertiary, secondary, and different types of isomers. All right. I hope you have gained some knowledge.